have one type of problem left in this topic with inverse derivatives, and that's how do you do these problems when it's presented in a table format. I'm really happy that the AP test puts this format on here because it is a common one on the AP test. You'll remember that we did all our other derivative rules in like a table kind of generic format. We did product rules this way, we did quotient rules, chain rules, etc. So this is just kind of an extension on that. So here's how this works. They are going to tell you what function you're working with. So we have this function f, and this table involves f and its derivative, and it wants to know the derivative of its inverse at 7. So here's how we do this. We are going to first write down what function it is that we're deriving. So we're deriving f, and we're going to reciprocate it. So those first two steps, derive, reciprocate. Now here's the key. 7 is not the number we're going to put into the derivative. Instead, I want to see when does my function equal 7. So my function equals 7 right here. You're looking at that f column. So what that means is you're actually plugging in -5 as your x value. Now this is nice the way it's set up, because if I want to know f prime of -5, it's just going to be the very last column in this table. So you're going to end up with 1 over -7. So you're using everything in that line because the 7 that you're given is actually what you want the function to equal. So you're going to truly just type that number into Delta Math. So I got -1/7. So I'm going to type in -1 divided by 7. Again, these are all numeric, which makes it typing in so much easier. Let me show you another one just so you can see it. I want to do a table 1. Here we go. All right, so this is saying that we are looking at g being the inverse of f, and I want to know the derivative of it at 5. So I am looking at the derivative of g. Get my pen here. And I want to reciprocate it. Just give me 1 second to do that. So I want to know when g prime and finally, I want to look at the table and figure out when does this actual function equal 5. That happens at 9. So what I'm actually doing is g prime of 9. I guess I should write this the other way. I should say f is my original function that I'm doing the inverse. So g prime of 5 is actually saying what is the reciprocal of 1 over f prime, and then I'm putting 9 in, and I get 1 over 4, this value right here. So again, reciprocating your original function actually is f. G is just representing the inverse of it, and then taking 1 over that derivative, and then making sure that this is the value that that function actually equals, so you know where you're looking in your table. So we're going to type in 1/4. This one was actually written a little differently, so I'm glad I did this one with you. I think the rest of them are written the same. Let me just do a quick double check to make sure you're good. Yeah, they're still written the same. So this one, your original function is f. We are taking its inverse and its derivative. So I'll kind of go through this one real quickly. So we're doing f prime, reciprocate that. Instead of plugging 2 in, we want to know when my original function equals 2. That happens at 6. And I love the way Delta Math sets up this table, because then all I have to do is look a little further to see what that f prime value is. It is -1. So we get 1 over -1, which indeed is -1. And that is your answer. So again, as I said in the first video, not the most exciting derivative rule at all, but hopefully one that after you see the different ways problems it can be presented, it's not that hard.